How many of you have read the blog post on the layered tool pattern? A couple hands. All right, cool. This is going to be all new for you. So I want to start things off and this is going to actually feel slightly ironic. I didn't think about the fact that I was putting a Sherlock Holmes quote and I was coming to London until this morning. So I'm obviously not being very observant, but I want to say, like, most people overlook details that are in plain sight, and a lot of the skill lies in the ability to notice and analyze what other people ignore. And I'm actually kind of curious, like, what would Sherlock think about how we are building tools today? And I want you to sort of keep that in mind as we're like working through this talk of like the idea of observation and how it can like help inspire us. So a little bit about me. I've been at Block for a little over 8 years. I'm API design lead. I've been doing that for probably 5 of those years. And that was like mostly on the Square developer platform. Now my focus is on internal and external developer products. And I'm almost exclusively focused on AI adoption and utilization at Block. But what I really want to talk to you about is one of our brands here, which is Square. So if you're not familiar with Square, here's some just stats from 2023. If you're not familiar, we process payments. That's what you're mostly going to know us for. We also have a bunch of tools for helping you in running a business. I know outside of the US, probably not as well known, fairly well known within the US. And why we actually are talking about this is that in 2015, we first launched our APIs. It's been about 10 years. And so this has grown to over 30 plus APIs, 200 plus endpoints. And so it's a very large, sprawling collection of tools. And so when MCP first got announced, me working on API design, I was like, great, this is perfect. I want to go build an MCP server. So I joined a team and we were like, okay, how do we actually build an MCP server? But then the question was like, how do you build an MCP server for this entire platform? There's a lot of different APIs. There's a lot of different endpoints. Some of them might have crossover in utility. How do you actually shape and get an LLM to use the right tools? How do you actually structure your tools? We were asking these questions and we were just hammering away, and we ran into a lot of issues. Do you create a tool for each endpoint? No, that was definitely a clear failure for us. You don't want to do that. Do we create individualized workflows? We were like, that sounds really interesting, but how do we actually figure out what are all the different workflows? I feel like it would take too long for us to actually analyze how developers are using this thing. And you're kind of in a catch-22. We're only going to figure out the workflows by actually having the MCP server, so how are we going to get there? So then it was create tools to explore our OpenAPI spec. And me working and designing our OpenAPI spec, I of course said, tell me more. So 2 people on our team, Mike and Max, I would definitely say a lot of credit goes to them of coming up with a lot of this stuff and building it and implementing it. But once we actually went with this approach, we really observed something awesome. We were able to see something just take this large sprawling thing and just seamlessly start completing tasks with very little error rates. And just to give you a sense of this is really only taking all the paths of our OpenAPI spec. It's huge. It's not even we're barely touching into the schema at the end there. This is what led us into the pattern that I think is actually what ended up solving this for us. And of course, you saw it in the title talk, but it's the layered tool pattern. Now, this kind of takes that entire API spec of the 30 plus APIs, 200 endpoints, and our MCP server. You can go look at it today. It's literally just 3 tools. And so those 3 tools, they have different names under the hood, and I'll get to those in a second, but they essentially break down to 3 different functions. One is for doing discovery, another one is for planning, and a third one is for execution. Now, what do I mean by discovery? Now, this tool is just going to be called the get service info. We basically took that entire OpenAPI spec, and we already had this annotated in order to display it in our documentation. And then we took all of that information architecture annotation, and we broke this up into collections of services. So now the LLM can actually just go ahead and call the discovery tool and say oh, somebody mentioned payments. Let me go see, is there a payment service? So it goes and sees there's a payment service and goes, great, what are the different methods in there? It figures out the methods. And then it has to actually go, okay, I figured out what method I need to use, but how do I actually call it? That's where the planning tool comes in. So the planning tool is actually going to say, like, here's all your type information, here's how you formulate a request. And so then the LLM can figure out what information in the prompt do I map to a request. Now, I don't want you to think of this like strictly a linear process. Discovery and planning can actually oscillate over and over and over again until it finally figures out everything that it needs to eventually make a request. So you might find that there's like a dependency somewhere within an API. Like I go and like say call an invoice, and I need an order, I need customers, I need locations, and it figures that out in the planning phase and goes, oh, I need to actually go back and figure out like what are those different services and how, like what methods do I need. Then so the planning tool is really just kind of like figuring out how do I actually map my data. And so that's just called like the get type info. We actually built that by just taking our type information from our TypeScript SDK. And so you can think of like those two tools as being like fairly static. And then the final tool, the simplest tool, is just execution. It's just make an API request. And I think this is all going to make sense when I show you an actual demo of this. So again, you might be familiar with this. This is what Angie was talking about just moments ago. This is Goose, and I'm going to show you how we actually can use this to run through a flow. So here, I'm actually just going to have it run through a demo, and I'll pause really quick. It's a little hard to see, so I'll tell you what it's actually saying here. I'm telling the LLM in here, just let's create an invoice charging Richard Moot for 2 hours of consulting at $250 an hour for MCP consulting, and this is actually just going to go ahead and like run through. It's not a very descriptive thing, but it's telling it needs to create an invoice, who the invoice is for, and what we're charging them. So we can actually like have it go through here, and then you're going to see that it's going to go through discovery, and in like the first instance of the discovery, you can see that it found, okay, you want to create an invoice. I found a create invoice method. Here we go. Let's actually like just start running with this. And then so it then goes into this planning phase. And you can see like as it does the planning, it finds out like, okay, there's a create invoice, it needs a publish invoice, there's a way to like list them and cancel them. And so it's already figuring out like, okay, this is actually how I want to achieve this. But then you can see in this like layer 2 of the planning, it requires the invoice object, but then there's these other fields. And that's when it actually figures out like, oh, there's other dependencies here. So it's actually going to go back in this pause of saying, hey, there's these missing prerequisites. And so here it's actually just doing additional discovery and planning to figure out what other services do I need and how do I call them. And so you can tell like right now, I'm not interacting from the initial prompt. It's actually figuring out, doing all the turns and figuring out like how do I actually like use Square's API platform to achieve this particular task. And so from here, it's just going to keep iterating through that discovery planning phase. And then after it's done all of that, it's now just hammering through a bunch of requests to get this data and then map it back and figuring out the sequence that it needs to run it in. And so you can see like, we'll kind of skip to the end here, but you can see that it's like hammering all through of that, and then we finally end up with an invoice at the very end here. Yeah, you can see like right there. You can see that it actually created this invoice. It's for me for $500, and it's in a draft phase, and so it's just going to publish it and send it to me. And at that point, that was just from one little kind of vague prompt, 3 server tools, and an agent was able to figure out exactly how to go create an invoice, send it, price it, everything. Now, most of the engineers who worked on this with my team, we were like flabbergasted when we saw like, hey, like Goose can actually just go ahead and do this thing. And we were like, great, let's go ship it. We launched it. And I would be quite honest that the rest of my team just thought, cool, it works. Let's move on. But I really got stuck because I thought, why does this work? I mean, it's not sufficient to me that it does work. I really want to understand why. That's part of the reason why I had to write a blog post and say, hey, there's this layered tool pattern. But since then, I've been thinking about this a lot. And kind of like when somebody tells you, hey, there's a lot of red cars in this city. Now, you don't know whether or not there's a lot of red cars in this city, but as soon as I say that, you suddenly notice them everywhere. And I feel like that's a lot of how we work with pattern detection. And so I got really hung up on the layered pattern, and I thought, like, this is something that I'm seeing, but I feel like I'm seeing it in more places. And so then I started looking outside of tech. For those that aren't familiar, I came across this from, it's like through somebody that I knew through my wife. But in the medical field, they have this strict pattern of how to actually do their own analysis of like handling a patient, writing their notes. And it's just called the SOAP method. I kind of consolidated things just for my convenience of matching our pattern here. But subjective, objective, you can really think subjective is like what the patient says about their problem. Objective is like what the doctor or the therapist is seeing in observation and treatment interventions. Assessment is really like the therapist's analysis of the various components, and then the plan is how the treatment will be developed and then actually executed. And so it very clearly shows that like subjective objective is like doing the discovery phase, trying to figure out what are you saying is wrong, what do I see that's wrong. Assessment is like, okay, based on what is wrong, what are the different ways that we would actually like do anything with this? And then the plan is really just like, okay, like you need this medicine, you need this therapy. And then I also kind of thought that this fits within the scientific method. For those that aren't familiar, you just basically you observe something in the world, you create a hypothesis, and then you go experiment and you test that hypothesis. And so I feel like that we're going to keep seeing this in multiple ways, and I'll keep showing them. For those that aren't familiar, this is like bringing this back into the world of tech that I came across, completely independent of us. If you're not familiar with Dex Horthy from Human Layer, he gave a talk on context engineering, another one on advanced context engineering. I highly recommend checking those out if you're wanting to like learn how to get beyond vibe coding. But he basically articulated a way of using subagents and slash commands to like, do this, and check out their open source repo. They have a lot of really good Claude use cases, but he basically talks about getting beyond vibe coding is through these 3 different phases that you actually work through in 3 separate or more context windows. You have a research phase where you're actually like researching through your code base to try to figure out like everything that your code base is doing. What are all the things that I need in order to actually make a change that's going to like accomplish the goal that I want? Then you go into the planning phase of like, okay, now given the research that I've collected, how am I actually going to go and do that implementation? Each one of these stages, you're reviewing what is the research, is that valid? What is the plan, does that make sense? And then by the time you get to the execution phase, you probably don't even care about the code itself because you almost already know what that code is going to look like. And so he very much talks about this idea of like, he actually cares more about the research and the plan because that's your spec, and that the code itself almost is just understood. But this kind of got me to this idea that like, this is maybe stretching it a little bit, but that intelligence navigates through complexity through these 3 phases, is that we do this kind of discovery, we eventually then make a plan, and then how we actually go do it. This is what we ended up kind of seeing with how a developer came into our platform. No one comes into Square to say, oh, like I want to go create and implement payments. They're not going to go straight into our API and be like, oh, I'm just going to go make an API request. They're going to go like, well, first I come here and like, well, do they have a payments API? Let me go find it. Okay, I found it. How do I actually make the requests? I need to plan that in my code. Then they actually go try it. And I feel like a lot of tools that you see are just like almost like this direct mapping into just going to make an API request. And I don't think that that's how people work. And that's the reason why LLMs can fail very easily with this. So to really just like hammer this home, there's other places where we see the layered tool pattern cropping up. And so I don't want to try to suppose that like me writing this blog post is what caused this to happen. I really am trying to make the point that this exists everywhere and we're just seeing this happen organically. So even with Goose's extension system, this one's slightly unfair because Max, who actually gave us the idea for doing the layered tool pattern, this actually very quickly after we did the MCP server, we decided we need to implement this within Goose because this is what enables Goose that even though you can have a bunch of different extensions or MCP servers installed, you don't necessarily have to have them activated, but you might give it a prompt and you mentioned GitHub in your prompt. Well, Goose will then go, well, let me go search. Is there like a MCP server for GitHub that I could use, and would that be useful in this context? So it will then go do a discovery. It will then find, oh, there is this tool. Now I need to actually plan, like ask the user, hey, do we want me to like use this tool in this context to solve this problem? And then it will go and execute. A lot of database MCPs or in databases themselves kind of work in this flow where you have the schema, you need to understand what are the different tables that are available. Then it's going to do query planning to figure out what is the right query to like solve this problem, and then it just executes it. And then GitHub has also run in this like similar kind of segmentation where they have like their tool sets of MCP tools, and then there's like their schemas and then the actual action. So like one of those might be like, what are all the different repos, code, trees available? How do I actually go make those changes within Git and stage them? And then actions are actually then go push this into a repo. And so in applying this pattern, this is like really kind of like trying to extract down beyond this, is in discovery, planning, and execution. Like, I think that in discovery, you really want to make the invisible visible. So this is really just trying to say, like, what are the things that are available? It's not being prescriptive. It's just saying these are the different things that exist within my API platform, my data set, whatever. Planning is then just trying to transform that intent into a structure. How do you actually map this in a way that your platform can actually understand when the tool is finally going to be called in execution? And execution is just do it. Like, just do the thing. Don't try to make this more complicated. I'd also kind of put it like through, well, I'll skip this part, but the counterintuitive truth that I kind of found within this is that making tools dumber made agents smarter. A different way of putting it is that by making it a lot simpler, it actually made it more useful to an LLM. And so I do have to kind of like lead this into like one more rant of mine to kind of like hopefully inspire you into what is actually going to like make it useful for you to go and figure out how to design tools in the future. When we first created this, one of the first things that somebody on my team said, who is like a lead engineer on our API platform, is he said, we need to go redo all of our APIs to be more agent friendly. Now, I'm not against that, but my pushback was, I think that the reason that this is useful is because they're trying to design and train LLMs to navigate the world in the way that we navigate the world. If you try to then work against that by creating APIs that are only going to work for machines, well, now you're only serving one audience and you're making this like less useful, less friendly to people. And so you should be designing for people because that is what agents are trying to be more like. And so we had every reason to organize this by service boundaries, keep it in like the REST world, authentication. But again, we somehow accidentally mimicked how like humans interact and understand our platform by just mapping how we did information architecture, which is all designed for how do people best understand how things work in our ecosystem. This is just like a small little take on what tools reveal about their builders. A basic tool definitely shows the builder's choices like, hey, here's what I made. A better tool might say, hey, here's how this works. But I think the great tools are, here's how people work. And I think you really need to focus on like human user workflows. This kind of goes back to like regular user design, is it's like figure out what actual users are doing, and your tools should kind of follow in that same kind of pattern. And then I finally want to kind of like lead a part of like a person who's like been sort of an inspiration and a little bit of a meme in the vibe coding community. Rick Rubin, he's a very legendary music producer if you're not familiar with him. He's produced Jay-Z, Tom Petty, Red Hot Chili Peppers. He's very famous for producing all these people, yet notorious for not actually playing musical instruments and not understanding how to work a soundboard or any of these things. He is like the quintessential person of vibes. But one thing that he has all of his artists read is Sherlock Holmes. And I thought that was actually very interesting. And part of that reason is that he has the artists read Sherlock Holmes because of observation. The idea is to have them be more present and like look at the things around them and then be inspired by them in order to create art that actually like means something to them. So I want to leave you with this idea to see beyond the obvious, notice what others overlook, and turn curiosity into discovery, because I think attention fuels that curiosity, and then that curiosity leads to discovery, and then you're in the discovery, planning, execution pattern. So with that, I sort of leave that as the layered tool pattern.